In this video, we'll focus on the basic adjustments needed to make proper use of our products and obtain your first 3D capture. In other videos, we will take a deeper look at additional software parameters, but today, we'll concentrate on the essential first steps to help you understand how the system works and familiarize yourself with our technology. Configure the parameters to ensure optimal operating conditions. To start, make sure the lighting and focus are properly set. Open the Camera Parameters menu. To start shaping your scene and obtain an accurate reading, make sure that View Post-Processing is disabled. Post-processing is useful for improving the 2D visualization and the point cloud, but it should remain off during the first configuration. As you can see, while streaming, exposure time is set to automatic by default. However, for better control and image consistency, we recommend switching to manual exposure and adjusting it according to the lighting conditions of your scene. Next, we're going to look closely at the raw histogram to adjust the lighting settings, since depth information is derived directly from this data. Ensure the image is neither overexposed nor underexposed. Excessive lighting will push the histogram towards the right, reaching the saturation limit. Insufficient lighting will shift the values to the left. The ideal setup is a histogram with most values balanced around the center, indicating a well-exposed scene. Now that the lighting is correctly configured, we're moving to the Processing Parameters menu. To place the camera in its best focus position relative to the object, use the Optimum Target Distance visualization parameter. Move the camera closer or further away until you see the object is displayed in this color. By hovering the mouse pointer over the image, pixel values will be shown, and you can also check that the distance value is close to 0 millimeters. Now, you can change the visualizer to sparse depth to check that you have focused correctly according to your camera specifications. You can examine the datasheet of your apiCAM camera to learn about the optimal performance distances for your product and check if it matches your values in sparse depth and in the depth range. On the depth histogram, you can see the range of depth distances detected by the system. This option helps visualize depth as a color range to understand distances between objects. Consider that the depth map values are not changing even if you change this range, because this is just for visualization purposes. You can adjust the range to display the depth values you need. If Show Out of Range Values is activated, everything outside the depth range will appear in purple. However, these values will not be included in the point cloud reconstruction. If it is disabled, those values will not appear in the sparse visualizer either. Make sure you're including the right values in your depth range. When depth range is properly defined, everything fits correctly. Once everything is set up for proper visualization, check the rest of configuration options. Now, open the Sparse Parameters menu. The threshold controls the level of reliability required for depth reconstruction. Higher values require more precision, so some depth points will be lost, and only the most reliable ones will be shown. Lower values may introduce noise but provide a higher number of depth points. The Grid Sparse filter applies filtering to the point cloud values. It helps reduce noise and improves the results. When the filter is active, you can adjust the number of iterations. More iterations produce a smoother result, but they also increase computational cost and may over-smooth the point cloud. For example, here you can see a point cloud with this option enabled. And here it is when it is disabled. Once you have everything set up for your needs, you can view the point cloud reconstruction as you have seen before by clicking the Open 3D Visualizer button. If you feel like you'll need this configuration again, you can save camera session parameters, so you can use the same configuration the next time you use apiCAM Studio. You can either save it as default, which will change the default parameters of the camera configuration, or save it as custom for save it in your computer and use it when you choose. We recommend you to use this last option. If you want to use this configuration in a new session, or if you change something in this session and want to revert it, you can reload the configuration by clicking here and selecting your configuration file. Finally, click to save the picture you want. Save it as a PSA file, or choose from other formats. A PSA file is the native format of our products. It stores all configuration data, allowing you to reopen the project exactly as you see it now and adjust the parameters again if needed. A PNG file will save the results as images. You can export the 2D image, the depth visualization, or both at the same time. You have two types of CSV exports. You can either export the data of the depth map or the values of the optimum target distance. Point cloud is used to save the depth reconstruction. When you activate this option, new settings will appear in the menu. Choose the right export formats for your needs. If you saved your .psa, you can revisit it. Just open it again in apiCAM Studio by clicking the Open a .psa file button. Check out our next video to learn more about how to use our products so you can get the most out of them.